General prototype of a class. Class, this is the child class, and this is the description of the parent class. The word class, then the child class. For example, circle, then the description, which is public, protected, or private, of the parent class, which is shape in our example. And inside we have private, protected, public, public, where all the fields are public to everybody. Protected, only the children classes can see it. Private, no one but this class can see it. A child class inherits from parent class and implements some interface. Nested class. A class within another class is called a nested class. A class within another class. Just like if inside another if. Nested if. Compelling reason for using nested classes include the following. Why do we use nested classes? It is a way of logically grouping classes that are only used in one place. If a class is useful to only one another class, then it's logical to embed it in that class and keep the two together. Nesting, such as helper classes, makes their packages more streamlined. This is the first reason. The second reason, it increases encapsulation. Consider two top-level classes, A and B, where A needs to access a member of, where B needs to access a member of A that would otherwise be declared private. By hiding class B within A, A's members can be declared private and B still can access them. In addition, so this is the encapsulation, that's the second reason. In addition, B itself can be hidden from the outside world. So you can hide the class inside the other class, and that hidden class can access everything in the hiding class. So this is the second reason. The first reason, logical grouping. The second reason is encapsulation. The third reason why we use nested classes is it can lead to more readable and maintainable code, easier to read and maintain. Nesting small classes within top-level classes places the code closer to where it is used. A nested class has an independent set of modifiers from the outer class. Visibility modifiers. A nested class has an independent set of modifiers from the outer class. Visibility modifiers. Visibility modifiers, public, private, and protected. Effect. Visibility modifiers affect whether the nested class definition is accessible beyond the outer class definition. For example, a private nested class can be used by the outer class but no other classes. So this can be used by the outer class only. This private class can be used by the outer class only because it's private, it's internal. Okay. Let us take example of linked list and tree class. Both the linked list and the tree have nodes to store few new elements. Both the linked list and trees have their nodes different. So it is best to declare their corresponding nodes class inside their own class to prevent name conflict. This is the reason. And increase encapsulation. Why do we put a linked list nested class and a tree class also in a nested way? To prevent name conflict and increase encapsulation. This is the example. The linked list, the class called linked list, it has a private class inside it, which is called class node. The node has a value and next, and node next. So this is value and this is node next. It's a pointer to the next. Nested class node, other fields and methods. And we have node, another pointer called head. All right, this is part of the linked list because this class is over. And we have also something called size, and this is the linked list other fields and methods. Goes here after we close the node class, or in the tree field. So that's the linked list. It has a pointer called next and a pointer called head and a size integer and an integer value. In the tree, we have also a nested class called node, and unlike the other one, well, so far they look alike. They have node, they have the value as well, but here they have the left and right. The tree, they have two branches, the left child and the right child, like two branches. Nested class, other fields and methods. Then we close it, and this is the end of the node class inside the tree class. And then we have another variables under the private section, the tree, that's part of the tree, they call it the root. So the tree has really a root, a value, then left and right, 4 things, while the linked list, they have the value as well, but they have the next and the head, and they have the size, not the root, the size. All right. Enums restrict a variable to have one of the few predefined values. Select from the options. It's not all options are available. So enum class, it gives you a small, medium, and large because it's called bulb size. So we have 3 sizes of this bulb. Enum class has three things. Class bulb, it has the bulb size, public, and here we have the get bulb size. I think this should be B, bulb size. And here we have set bulb size, getter and setter, where here it gets the size and here it sets the size, this one here. It changes the value of this parameter. And in the main program we have the bulb B, so we defined a class from the numerator here. No, here we define this one first. Then we call this set bulb size, and we set it to be medium, bulb size medium, because this is the enum class is all public. So this is all public. It can be accessed from the main. When you type whatever variable that has this type, okay, or can you type this and then 2 colons, then all these 3 options are accessible, just like this. And if you type bulb size equals this buffer size, get buffer, the returned value. In the above code, we made some changes to the bulb class. It has one more field. It's the size, and the size is type of a new bulb size. And the allowed values of the size are small, medium, and large. This is the analysis. So the enum, this one here, it restricts the result to be one of these three. All right. And here we did the set and give it this name. And here we are just printing bulb size. All right. Constants, another thing to remember. Constants are defined by using const modifier. The const modifier indicates that the value of this field cannot be changed because it's a constant, it cannot be changed. Like constant double, and this is pi. All right. Another example is another example in this, we had created a constant of string type, so this is also a constant. And this is string. We have to include the C string on the top, okay? And we save this constant. So we cannot really change the value. We cannot change the pi, say pi equals pi plus 1. We cannot do that. We cannot concatenate. We cannot add or remove letters to this string. It's a constant. That's why it's called constants. Conditions and loops. The if condition, as shown here. If the condition is established or done, then go to the next, or the condition is true. Otherwise, don't do that. Just skip whatever after the if. So if this condition is true, do this. Otherwise, just skip from here to the end. Don't do anything. All right. And then we have the nested if and if else, while loop. And here, all the variables stored in the array are added to the sum. So we defined something called vector, which is an array. Vectors are pretty much like arrays. We just say vector, then we specify its type. Then we give it a name. And we put it inside, just like an array, right? Then we say, treat it like an array. Treat this like an array. But this is called vector, okay? All the variables stored in an array are added to the sum variable. This equals numbers plus, this equals sum plus numbers, right? Plus and equal means sum equals sum plus numbers. And the index is I inside the loop, okay? Are added to the sum variable one by one in a while loop. So this while loop just start accumulating, all right? That's how the while works, and the do while is similar to the while, but only the difference is that the conditional code is executed before the test condition. The do while is used where you want to execute some conditional code at least once. So it does it once, at least it takes a step, then it checks. All right, and here's an example about the do while. Also to calculate the sum of a vector, and the for loop for the initialization, and the condition that needs to be true for this to be accomplished, and the increment that is called after each iteration. And here is the flow chart. right? And here's an example of the for statement. For loop works well with basic types, but does not handle collection of objects well. For this, an alternate syntax for each loop is provided. So we have for each. C++ does not have keywords for each, it uses for keywords. So the for and a declaration, then colons. Instead of 2 semicolons, like in the for, we have 1 colon, then we have the collection or array statement. So this is like another version of the for statement. So we have the vector here, it's called numbers, just like an array. And the sum is assigned to 0 at the beginning. Then we have auto n declaration, auto n. And we have the numbers, and then we have sum plus unequal n. This does the same accumulation. This is really advanced and pretty nice feature. And we have the array type. The arrays just like the vectors, and here's the type, here's the name of the array, here's the size of the array, and it always starts from 0. So when we say 10 elements, it's from ARR 0 to ARR 9, and that's 10 elements. So it starts from 0 and it's less than 10 to 9 because it's an integer, right? So from 0 to 9, and we print that. So for here we are pretty much printing print array. That's nice. So we have a print array code. Void array example. We have defined the array integer type, then we do the loop from I equals to 0, as the condition is it should be less than 10, and the increment is by 1. Then we do the array equals. So the first element is assigned to 0 and the last element is assigned to 9, and here we just print the array. Analysis defines an array of integer, and it's called ARR. The array is of size 10, which means it can store 10 integers inside it. Array elements can be accessed using the subscript operator, using these two big brackets without the dot. Lowest subscript is the first element is 0, and the highest subscript is the size of the array minus 1, which is 9, because the size of the array is 10. Values 0 to 9 is stored in the array. Array and its size are passed to Printarray method. So this is really a method. The name of the array and its size. All right. The Printarray method is like this. It's a method that takes two integers, the array. See, it takes an array here. And when we pass it, we didn't really put the two brackets. We just pass the name. But here in the definition of the method, we need to put that. The size is the count, and here we just print out. We do a for loop from 0 to less than the count, and we print every single element in its own line, because we end line every time we print. All right, array variable r and its variable count are passed to argument print array. So this is a method that we created, we wrote, and finally array values are printed to screen using the cout In a for loop, we use the for loop. Points to remember, array index always starts with 0. The subscript operator has the highest precedence. If you write ARR plus 2 plus plus, then the value of 2 will be incremented by 1. Vectors. Vectors are store multiple data elements of the same type in a contiguous storage location, just like an array. So they are just like arrays. Their elements can be accessed using offset and are as efficient as arrays. But unlike arrays, the size of vectors can change dynamically. You know the difference now? Vectors, the size of a vector can change dynamically. The data storage is handled automatically by the vector. Okay. So if we wrote a method here and call it vector example, and we define a vector of type integer and call it vec, then we use the for loop to call pushback I. This is a function. This is a function. And this is another function that we are calling. We need to define it. Print vector, and that's another function. So we have two functions to write, this and this. Analysis, define a vector of integer and call it vector. Values 0 to 9, here from 0 to 9. Is added to the vector by calling pushback method. So we are calling a method and passing the I parameter. Vector is passed to the print vector method at the very end. No need to pass size of the vector. It keeps track of its size too. Remember when we did this for the array, we had to pass the size of the array. Here, we don't have to do that. So the print vector, how does it work? So the pushback is really saved, and it's a way of assigning. But the print vector, we need to write it down here. Print vector, let me see, yeah. Print vector contains a vector and a pointer to that. It takes a pointer to a vector, and the way it's called, just like the array, we just put vec. Over there, we just put ARR, okay? It takes a pointer. Here, it says data.size, so it can pull the size of the vector. No need to pass it. In the arrays, we cannot really know the size of the array. In the vectors, we have a way of knowing the size of the vector. And we just store it in a variable called count, and we start from 0 until that count, and just start printing cout, printing data. And this will print it only in just one line and put space before everything that they print. Unlike before, we were printing everyone in a separate line, and we used the end L end line. All right. And analysis, where are we? Okay, we just read this. So analysis, size of the vector is stored inside count variable. Yeah, the loop is executed for all the elements of the vector. Finally, vector values are printed to the screen using the cout or std : cout. And we have these points to remember.